All right, guys, today we're going to look at the second half probability distributions. So hopefully, if you have questions, please make sure you get in touch with me via email or Zoom. All right, so what we're going to look at today is we're going to look at the mean, variance, standard deviation of our probability distribution and talk about what is called the expected value. All right, so the mean of a discrete random variable is given by formula mu. Okay, so this is going to be a population, so we're not going to be using x bar right now. We're going to be looking at mu, and then we are going to be talking about the summation. So here's our funky e. Remember, summation means we're going to add up everything, and we're going to do x times p of x. So basically, you're going to take your random variable and times it by its probability, and then we're going to add them up. We're not dividing anything. That's all we're going to do because p of x, remember, is the probability, so we already divided by the total when we found that, so we don't need to divide again. And then you have your variance. And your variance and standard deviation, again, we're going to be using omega and omega squared because we are going to be talking about population. So omega squared, remember, is your variance. Okay, so that's going to be the summation of x minus mu quantity squared times p of x. Now that should look familiar because that was our kind of very similar formula when we did standard deviation by hand, and we said we were only going to do it once and only once, and the rest of the time we can use our calculators. Unfortunately, there is no calculator function for population or for variance of a discrete random variable. Sorry, we're going to have to make a chart and do it by hand. I apologize for that. There's nothing I can do about it. And our standard deviation is going to be the square root of that. Okay, so we're going to do a problem involving this. All right, so this is the guy that we worked with yesterday, and we had the aggressive behavior, and we found all the p of x's. So we don't need to make it again, so I'm just going to add that information into our chart. I'm going to always give you the chart, guys, so you don't need to worry about filling it in, but you are doing the tops. But remember, x is going to be our random variable, so this went from 1, 2, 3, 4, and 5. P of x, remember, was the total of 150 divided 294 divided by 150, 33 divided by 150. So remember, those are the things that we did yesterday. So our p of x's, when we created this yesterday, was 24 divided by 150. Okay. So when we did this the other day, this is what we got when we did that division. Okay, so we're going to take those p of x's and we're going to add them into the chart. Okay. All right, and again, double check it's valid. So when we add a p of x, we should be equal to 1, which it does. Okay, so now we're going to do x times p of x. So we're just taking the first two columns and multiplying them together. Okay, so now we're going to find our mean, our mu, and remember that's going to mean we're going to add up the total of x times p of x. So mu is equal to summation of x times p of x. So we're going to total up that column. So we're going to add, okay, so we're going to add all these guys up right here, and that's going to give us our mu. All right, so I did that earlier and I got 2.94. Unfortunately, I didn't do the rest, so we're going to have to do this together. So 2.94 is our mean. So we're going to take each of our x's and subtract 2.94 from them. Okay, so 1 minus 2.94. Okay, and you're going to get negative numbers, and that's okay. Okay. All right, there we are. Okay, so now we're going to have to take all these numbers and we're going to have to square them. And yes, you're going to get some very large numbers. Okay. Try not to round. Okay, mine is set for 3 decimal places. Please don't round because you're going to end up slightly off, and we want to be as exact as possible. Okay, there we go. All right, and now what we're going to do next is help us find the variance and standard deviation. So if you notice, this last column says x minus mu quantity squared p of x. That means we're going to take this x minus mu quantity squared and times it by the p of x column. All right, so please be careful. People have a tendency to multiply the two columns or the wrong two columns. So please be careful. Okay. So 0.884 times 0.22. And again, as you're working this, please double check my math as well. Okay. So high risk of making mistakes with this particular concept. All right, so when we do this, now we're going to take this last column we just did and find the total. Okay. All right, so that's going to give us our variance. Okay, so remember, summation of x minus mu quantity squared p of x. So that's going to be that last column, and we're going to add those up. Okay, so I got 1.6116, okay? That is our variance. So our standard deviation, remember, is the square root of that. Okay, and I got 1.271. All right, so that's going to be our process, guys. Not exactly the easiest method to get there, but it's guaranteed to get us the correct answer. All right, so we're going to put all of the concepts that we just did together in a problem. All right, so yesterday and a little bit of today. So we're going to construct a probability distribution, then we're going to graph it, and then we're going to find the mean, variance, and standard deviation. So we're going to put it all together before we move on to expected value. So why don't you guys pause the video, and then we'll come back and see how we did. So I'm going to work on this. If you want to pause it, try working through it and see if we all get the same answer. Okay. All right, so check your P of X, or sorry, we need a total first. My bad. Okay, so our random variable is goals, and our total is the number of goals during a 32, I'm assuming. It's not 32 because that's the number, not the number of games. It's the number of goals. Oh, it turns out to be 32. Okay, so we're going to take each one of these guys and divide it by 32. All right, so there's my distribution. There's my P of X. So there's our probability distribution. So that's the first thing done. All right, we're going to make a graph of that and double check your validity. Make sure it's all between 0 and 1, which they are. And please make sure they add up to 1, which they do. Okay. that down a little bit. Remember that going across is going to be your random variable, and vertically is your P of X. Okay, so our random variable is across the bottom. So our random variable is 0 through 5. I think we can make it wider if you choose to do so. Three, 4, and 5. And then our P of X goes from, we have 0.03 through 0.3 on. So let's go by 3s. Let me double check that. Yep. Okay, we probably could have gone by 4s. That's okay. All right, so we're going to graph those. All right, so 0 had 0.21. Okay, best approximation of where the location would be on the graph. All right, so 1 was 0.25. Stick that right in the middle. And try to make your bars the same width. 0.31. 0.049, so that's down here. Again, it may be symmetric, it may not be. Okay? It just depends on the data that you've collected. It's nice if it is, because then it would follow empirical rule. Okay, so there's our graph. All right. So that's not too bad. All right, so now we get to the difficult part of doing our mean, variance, and standard deviation. Okay, so goals are our random variables, so 0 through 5 in our chart. Okay, P of X. Okay, all right, so now we have to do X times P of X. So remember, we're going to total that to get our mean. Okay, so add that column up. Okay, I get 1.689. So there's our mean. So remember, we're going to use mu to designate our mean. Okay. All right, so now we have to take each one of our x's and subtract our mean from it. Okay, so this would be negative 1.689. Just check that last one. Nope, I was ahead. I missed something. Oh, that should be 3. I skipped the number. All right, so remember, we're going to square that. Remember, no negatives when we square. So you can just ignore them when you write it. Okay, and mine is rounding to 3 decimal places, so, which is perfectly fine. Okay, so now we're going to take those numbers and times it by our P of X. Okay, so 0.219 times 2.853. Okay. Okay, and keep going. Oh, that's not right. Okay, so remember, we're going to take this last column. We're going to total that. Okay. Okay, I got 1.778 as our variance. So our variance, 1.778. And remember, our standard deviation is the square root of that. .333. Okay. All right. So hopefully that helps you out. Now we should be able to interpret what this means. Okay. So we would say that the average goals scored per game or per season is 1.689. Okay, so the average score, average goals. It's 1.689 goals with a standard deviation of 1.33 goals. Okay. All right. Very good. Hopefully you got that correct. Our last topic is going to be expected value. Now we've already done expected value. We just didn't call it that. The expected value is what we expect to happen. What is expected to happen. And another word for this is average. So basically, I just spelled that wrong. Okay, is expected value is the average of our probability distribution. It's what we expect to happen. So we use this notation E of X for expected value, which is the same as the mean, which is the summation of X times P of X. So we've already done it. We just didn't call it expected value. All right, so we use this when we expect to like win or lose something in the lottery or in some kind of raffle. All right, so here we have a raffle of 115 or 1,500 tickets that are sold at $2 a piece, and we have 4 prizes: $500, $250, $150, and $75. We're going to buy a ticket. What's your gain? Well, how much money should you expect to gain? So we're going to make our P of X P of X chart. I'm going to do mine horizontally. So here, X is how much money we expect to gain, and P of X is the probability of that happening. All right, so with this, we have $500 that we could win, but you paid $2 for the ticket, so you're only going to be expected to win $498. All right, $2 for the ticket. There's only one winning ticket, so that's 1,500. 1 out of 1,500 is going to win. So you would expect when we win $250, we're only going to win $248. Again, we paid $2 for the ticket. And there is only one ticket out of the 1,500 that's going to win. Now I know it's kind of like, did they win and put the number back? We're going to go with yes. Okay, we keep going. We paid $2, so that's $148. 1 out of 1,500. And then $75 would be $73. Okay, 1 out of 1,500. But we paid $2 for the ticket, so we're going to lose $2. So -2. And there are 4,496 tickets that are going to lose out of those 1,500 tickets that were available. Okay, so do X times P of X. So 498 times 1 over 1,500, 248 out of 1 times 1 over 1,500. When we do the math, we find that our E of X is 1.35, but it is also negative. That's perfectly fine. So what does that mean? That we would expect to lose $1.35 when we played this game. Okay? All right. During a 1-year selling period, 225 days, the sales represented me between 0 and 9 days shown below. What is the expected number of sales per day? So we're going to need to make a P of X and then multiply X times P of X. So let's make the P of X. Okay, so 225. So 25 divided by 225. Okay, this is not going to be right on target because my numbers are too big. Okay, so there's our P of X row. Multiply those by X and add them up. Okay? So All right, so I got 2.433, and that's going to be our expected value. Okay, so what does that mean? All right, so this is the expected value, the number of sales per day for the sales representative. So this is the expected number of sales per day. All right, guys, that was a little long, so hopefully it made sense to you. If you have any questions, please let me know. Have a great day.